Good evening, everyone. Glad to see you all here this evening. My name is Greg Natterer. I'm the Dean here of the Faculty of Engineering and Applied Science, and it's a pleasure for me to welcome you to our Speaking of Engineering lecture this evening. I'd like to extend greetings to our guest speaker to my right, Dr. Kamal Hossain, who is an assistant professor in civil engineering. Welcome this evening, Kamal. I'd also like to acknowledge Janet Bradshaw to my left here, who is the CEO and Registrar of Paganel, which is Professional Engineers and Geoscientists of Newfoundland and Labrador. Janet will come up later to talk about Paganel's sponsorship of this lecture series. This session is co-sponsored by Paganel, and as you know, Paganel is a provincial organization with the mandate of regulating the professions of engineering and geoscience in the public interest. It has approximately 4,000 members, and we're grateful for Paganel's support of this lecture this evening. Just a few housekeeping items before we get started. In case of an emergency, not that we're expecting one, but if there is an alarm, we should exit this room calmly and turn to the right, exit through the main front doors of this lobby, and then turn left, muster station in lot 22, which is across from the business building. Washrooms also are on this main floor, so if you just turn left as you exit this lecture theater. So this Speaking of Engineering lecture series raises the awareness of engineering issues among our university community as well as the general public. We're very proud of the work of our Faculty of Engineering and Applied Science, the professors, the students, the staff members. And so I'd like to take just a few moments to share with you some of that success. So a little bit of a commercial break before we get started. I had the highlight of my summer a few months ago was to visit a team of students who were competing in Los Angeles, our students, at the 4th Hyperloop Pod competition. They were really a very impressive group of students of about 40 who attended, not only engineering but business, as well as college students and others, as well as Northeastern University in the U.S. Over 300 teams entered this competition to build what they call a Hyperloop pod, and this is a very high-speed pod that moves through a vacuum tube that can go theoretically up to 1,000 kilometers an hour, and it's a worldwide competition among students in universities around the world. Over 300 teams competed. Was very proud to see that our students placed 8th in the world and 3rd in North America and 1st in Canada. So that was an amazing accomplishment with their pod that had a maximum speed of up to 470 kilometers per hour. Now, just an interesting story that I attend national deans meetings about twice a year. There are about 45 schools of engineering across Canada, and some of those deans are, well, many of them are very proud of their engineering schools. And this particular occasion, I met one of them, and I distinctly remember how he would boast about how great his School of Engineering is, how they're, the best at everything. So it gave me particular pleasure on this occasion in Los Angeles to ask him, how did your team do at the Hyperloop competition this year? I didn't want to rub it in, but by the way, you know who came in first, right? So, we were the best, actually. Our students are also very entrepreneurial. We have a Memorial Center for Entrepreneurship that was co-founded by our faculty in business about 4 years ago here at the university. And recently, the Global Consortium of Entrepreneurship Centers named our Entrepreneurship Center as one of the top 5 emerging entrepreneurship centers in the world. So we're very proud of that. We're in the top 5 in the world. Our director, Florian Villamay, has done a great job, and many student projects that have come out of this faculty have ended up going on to become startup companies. We have a few other exciting things going on, a new science and engineering building that's going to open next year, and a $24 million grant from the provincial government, federal government, and industry partners on a high bay lab expansion of this building that's going to also occur. So two really exciting infrastructure projects. Anyway, speaking of infrastructure, moving on to our topic this evening. And tonight's lecture, which is going to be about the road and highway infrastructure in the province, specifically road conditions and pavement maintenance. Dr. Hussein's presentation will examine the issues of potholes, ruts, cracks, and maintenance costs of roads in the province, Newfoundland and Labrador. He's also going to discuss how climate change will affect our road performance in the future. He's going to share his thoughts on the state of pavement and how various stakeholders can come together to make a positive difference and solutions. So including government, municipalities, contractors, and how MUN aims to work together to solve and tackle these challenges. As I mentioned earlier, Dr. Hussein is an assistant professor in civil engineering. He previously was a postdoctoral researcher at the University of Illinois and also the University of Waterloo in Ontario, two leading institutions for this, particularly this field of research. Dr. Hussein received his PhD degree in 2014, and he's been a member of a number of prestigious committees and international organizations looking at road conditions and highways. For example, he's a member of the Committee on Pavement Maintenance and Asphalt Sealants for the U.S. National Transportation Research Board, and he also has led a research task force at the Academy of Pavement Science on maintenance of roads and highways. At MUN, not surprisingly, he teaches courses in these areas, and he's had research that has been funded by the City of St. John's. So without further delay, please join me in welcoming Dr. Hussein for his presentation this evening.
Thank you. Thank you, Dr. Nutter, for the introduction. And thank you all for coming to listen to this talk. So basically, I'll be talking about our initiative on how we can improve our road, if we can, and basically through research and development. So as I talk, in between the line, I'll be talking about what are the major issues and how we can improve those issues. So in the first section, I will give a little bit about introduction, what we are doing recently, about my research group. And then in the second part, I'll heavily talk about some example from other jurisdictions, how people work together to tackle the road issues, to improve the road condition, some from US and some from home in Canada. And in that part, I'll also talk about why we need research program here in Newfoundland and Labrador. And then what are the major issues? I will examine those, and what are the possible reasons, and what are the consequences of those issues, and how we can solve those issues, major issues. Then recently, my two graduate students work on to understand the climate change impact in our roads. So I will highlight some results from that research also. And in the last part, I'll talk about how we can work together, as Dr. Nutter mentioned, between the stakeholders to tackle these issues. So as Dr. Nutter mentioned, we are fairly new. I just joined about 2 years ago here. So I have 7, 8 graduate students, PhD and masters. They are working on various topics related to pavement engineering. Sometimes some co-op students also join to help their research and getting some experience in our pavement field. So in particular, for the project, couple of students for last 2 years working on to understand the pavement physical condition, physical distress, and they're trying to model those conditions. What are the factors basically affecting to these issues? And one PhD student is working on to understand the climate change impact. It will be his PhD thesis basically. He's spending time for last 2 years on this. A master students working on to understand the various additive performance in asphalt liquid level, binder level. He will complete his thesis soon, next semester basically. So he tried different additive to enhance the pavement performance in Newfoundland context. Another master student is working on to understand which maintenance practice have least environmental effect. He just joined about a year ago now. And then another new master student is working on to understand the optimal thickness design for pavement for our context. Another master student worked about a year ago. He is basically working on some pavement data from federal source from US and from Canada to understand the long-term pavement performance from the data from federally managed highways section. And another master student is working on to understand which maintenance practice and pavement management guide will be best suited for our climate. So he just joined 2 semesters ago. Then the last one, he joined just this semester. He will be working on basically focusing on developing pavement mixture for city of St. John to address the issues that we see in St. John area. So in this part, as I said, I will be talking about some example from other jurisdictions, how they work together to improve the road issues, and in particular, what are the issues we have and why we need to develop our own program. We'll talk about that. So as I came here from University of Illinois, just starting with the University of Illinois example, I want to make it one thing very clear. It's very common in US, it's kind of model that their main university in the state partner with the Department of Transportation, State Department of Transportation, and they work together to produce the information, research-based information that is needed to improve their road performance. It's very common in all 50 states. For example, as I said, Illinois Department of Transportation partnered with the University of Illinois. This building is just for pavement research. They have 3 professors and many students working on various topics. Just a portion of the building showing this in this picture. This portion of the facility is just used for collecting the material from different road projects during the construction season, and then students work with this material to analyze the performance and to develop the different guide for improving the road performance. This portion of the facility just used for asphalt mixture level testing. This area used for just compaction and splitting. This is here compaction equipment. This is rutting equipment, and this is fatigue testing equipment. So basically all these equipment are used just to characterize the asphalt mixture performance. And this portion of the facility used for asphalt binder level testing. A lot of advanced testing needed to characterize the material properly. I don't know the reason. It should be labeled here. Probably some computer programming issue, so name is not shown here. And they also have a small scale field test facility. So after you characterize the mixture in the laboratory, you can also build a small section and then apply some artificial loading to see how that material or mixture is performing. I have a small video clip. If it works, we'll watch together. So basically, after you characterizing the mixture in lab, so you create the rot section, small pavement section, then you apply this artificial loading to see the rutting or other cracking issues in the little bit real world context before you do big projects. It's not the big university, also small university in the state. They sometimes take really big initiative for developing the research-based information that is needed for road network. So Auburn University is like our size, but still they have really big program, nationally leading program basically. This facility is just used for asphalt binder and mixture characterization. Also have really big field test facility to characterize the mixture. I have a small video clip that gives an overview about this facility. So let's see if it works. We'll watch.
America relies on our highway infrastructure. For over 3 decades, our National Center for Asphalt Technology at Auburn University has focused on improving our roadways by evaluating and developing new technologies to make our roads smoother, quieter, safer, longer lasting, and more economical. NCAT was established through a partnership between Auburn University and the National Asphalt Pavement Association. We take pride in our strong relationships with state transportation departments, contractors, and others involved in the asphalt pavement industry. We strive to provide practical research results that are relevant and implementable into practice. Our highly qualified engineers understand pavement performance every step of the way, from the laboratory to the field. We are also developing the next generation of industry leaders. Students have the opportunity to obtain practical research experience, and many former NCAT Road Scholars are now in key infrastructure positions around the world. The NCAT Test Track is the only facility that combines real-world pavement construction with accelerated loading using heavy truck traffic. Highway agencies and industry sponsors fund research on the 1.7-mile oval, where our fleet applies over a decade of interstate-type traffic in only 2 years. Structural test sections have embedded strain and pressure sensors to measure pavement response to loads for validation of mechanistic empirical design procedures. Performance is monitored on a continuous basis to evaluate rutting, cracking, texture, friction, and noise.
So when I say that every state university develop the partnership with the Department of Transportation, it doesn't mean that every university has this facility, but in each region they have field test facility, so they can really simulate or obtain the environmental condition that is needed for that region. So this is another example from the states, again, state of Wyoming. I was there a couple of years ago. This portion of the facility is just used for asphalt characterization, and they have all the state-of-the-art facility. All the university is not that big, but for pavement program, government basically makes that partnership to get the best return of the investment. So in Canada, in other provinces, we have from good to decent program. Again, main universities in the province have that kind of facility. So in Ontario, Waterloo, Queens, and Carleton has good pavement program. with all the facilities. So Ministry of Transportation Ontario has good program. They provide up to $1 to $1.5 million for doing pavement and transportation research. So they can provide the necessary knowledge and information that is needed for their road network. And in Quebec, ETS and Laval University has that kind of program. So they provide and produce the knowledge that is needed for province of Quebec. And recently, to strengthen the research capacity, Waterloo has taken another initiative that is Sustainable Pavement Engineering Research Program. So they generated from the public and private organization about $1.5 million to do the research and further update their specification and to enhance the pavement performance in Ontario. Similar model was adopted in Manitoba recently. They also developed similar program. Last year, they basically launched this program to improve their specification in Manitoba. So why we need a pavement program here in Newfoundland and Labrador? So we have about 20,000 kilometers of road, and our Department of Transportation spends a lot of monies to manage our road. So about $150 to $200 million is spent on our road program. We have huge amount of municipalities. They also spend a lot of resources to manage our road. It's a lot of road network. I really thank to them with limited resource. They're managing huge amount of road. But we have a lot of challenges also in our province. So I feel like for last, I saw 3 winter, it's all time probably raining in the summer or fall, or drizzling or fog deposition, and snowing and flurries in the winter. So you have lots of precipitation year round in the province. This is basically water. And water is enemy of asphalt pavement. Basically, the hydrogen atom available in water, it alters the binding capacity of asphalt, adhesion capacity of asphalt. So we need to really consider these in our design component. Furthermore, we have huge amount of freeze-thaw cycle, temperature fluctuating. So that's basically giving extra thermal stress in our pavement. So you see a lot of thermal related crack in our pavement. Okay, and these cracks are further deteriorated by the traffic and water action. So these are the major challenges. Last not but the least, huge amount of studded tire. Just to be honest, I spent 6 years in Waterloo in Ontario, then 1 year in Illinois. I never saw studded tire. So first time when I heard from my department head, I went to Costco to see the studded tire because I came in fall. And stud is basically tungsten carbide, very high strong steel. It has a grinding effect in our pavement surface. So these are the major challenges that we need to really think about to design our pavement, to design our asphalt mix. I'll talk on these factors in detail in the upcoming slides. So after I came here, I started to review the documents that is available on public domain, like our specs book, and also we have a good friend in Department of Transportation. I took the updated spec from them. I reviewed them. Of course, not in detail, but I saw the key features in the specification. So Still, we are a little bit behind on the asphalt mixture design. We are not only province that we are following 1940s method for mixed characterization, that is Marshall method. The main problem with this, it does not do the rutting test. It does not do any cracking test. But that's why people started to use SuperPEP system, that is 1990 system. So 7 province uses this system. And in the state, all 50 states use SuperPEP system. We specify SuperPEP binder, that's a good thing, but to my knowledge, I did not find SuperPEP binder testing system in our province for testing for my student project. As I said, Raihan, my master student, worked on binder characterization. So he needed to send the sample in Ontario for testing, for SuperPEP testing. Because our industry need to, I think, create capacity to do more rigorous testing, although it's in our specification book. Also, when you drive in the city street, I feel like every few feet there is a patching. Every few feet. And probably every few months we are doing same in the same spot. We have limited budget, I know. It will further deteriorate the pavement if we do not do temporary work. But that's also not the solution. Every 6 months in the same spot doing the patching work. So we need to develop life cycle cost analysis-based management program. And we need to rank our road based on actual PCI data, pavement condition index data. It's not that expensive nowadays to collect the PCI data, IRA data, and publish those PCI data. And based on that PCI data, we can take the proper maintenance action rather than doing patching work every few months. So people will also understand that no, we have limited budget. We cannot do maintenance work all 600-kilometer roads in the city of St. John same year. And then, as I said, I reviewed the spec book that we have now. I feel like we really need to update that spec book based on our precipitation amount, our freeze-thaw cycle amount, and if we need to continue start tire, we need to design our mixture based on started tire effect. There are some solutions for that also. And then pavement thickness design. Many states and provinces still use 1990s method, but people started to also explore MAPDZ method, that is advanced method for thickness design analysis. So we can also try if governments want. So this slide shows pictorial presentation where we are at with the mixed design system. So the green color shows they are using advanced system for mixture characterization, where we can do the rutting test, cracking test, different cracking test, and of course other tests, strength test, adhesion test. But the blue color region shows still we are using very old procedure for mixed characterization. In Canada, it's a little bit mixed. So at least the other 7 provinces use, for highways, the advanced system. For the local state, they still use old system. But people started to think about that we need to go through to 1990s method than 40s method. But in the States, it's very common since 2000. All states use 90s method, the SuperPEP method. So then I also saw a document online from Auditor General Office. So they also found huge issues in our road construction, specification, and management. The point I mentioned. So So we really need to do something together. I do not want to repeat this. It's an online document you can review. It's called Newfoundland Auditor General Report on Roadworks. And my student did some survey, very small scale. We surveyed randomly about 20 roads and collected some distress data. So we found ruts is one of the major issues, physical issues in our road. Some related to stud, most likely. Some related to asphalt mix design, again, most likely. And some related to binder selection, the liquid portion of the mixture. And we also have a lot of water-related damage, moisture-induced damage, that is pothole and raveling. Again, as I said, water is every day in Newfoundland, okay? It's just form is different. Then extreme freeze cycle, that also affects to create crack in our pavement from the thermal stress. And then we also have crack related to aging. Many of our roads built many, many years ago. So everything ages. Roads is also aging. So there are aging related crack because when asphalt ages, it becomes stiff. So with the traffic loading, it just breaks apart. It becomes more fragile. And rough pavement surface, high international roughness index, is basically mainly, I'm talking about this roughness from the poor patching work, uneven patching work. So when there is a joint are not level, I'll show some example of this distress. So for the start portion is basically raveling, but here we call it rutting from stud. Basically, stud is steel bolt, as I said, it grinds the pavement surface. Okay, so you see a vertical depression without any side hump, mainly in our highways. Okay, but my position is on this. I made it very clear in a couple of media interviews over the last 2 years. As we have more white pavement, especially in Avalon Peninsula, and white snow or slushy snow, it probably most likely not helping in our safety, road safety. There are so many other factors are related to road safety, driving safety. Stud will not significantly help in Avalon Peninsula because we have lots of time just white pavement or white snow, if not dry snow. And when you have white pavement and you have steel surface in your tire, you're basically creating more slippery interface. But if you have ice, glare ice or burnt ice on the pavement, yes, that can have more safety benefit. That's Nordic country did extensive study on that to see the benefit of studded tire. Japan banned studded tire. In 10 states banned studded tire, including Wisconsin. It's a very intensive state. Michigan banned. Illinois banned. Illinois is warmer, that's okay. Okay, Michigan banned. Minnesota banned studded tire. And in Canada, Ontario South banned. So we can probably think about this portion of the province. We can quantify the benefit if government wants, or the damage is making by the stud user. And some state in the US, they're thinking to give tax break to the people who are not using stud. Some kind of motivation not to use stud. So, but if we really need to use stud, like in state of Washington, they're thinking to adopt their mixture using steel slag. They already finished the research part. They found that steel slag can help to remove reduce stud-related rotting, because steel is much stronger than the rock, so they're using up to 40% steel slag in the mixture design to have the less abrasive action. So that's why I'm proposing if we really need stud, we can tweak our mixture using different material, or stone matrix asphalt, more strong rock than the fine rock in the material mix. Not only that, we need to also introduce stud testing, and we need to adopt that at the contractor level also, if we really need stud here. And rot related to pavement or asphalt mixture design, or asphalt related, binder related. So when you drive in the city road, you will see rotted channel. It's like tram line, and on the wheel path is depressed, and in the side you will see kind of humping or bulging. So that is occurring due to issues in mixture. If you have a lot of void in your mixture, so with the traffic loading, it densifies. Or if your gradation design is not correct, gradation design of the aggregate, you will see sharing failure in your pavement. So that occurs, this kind of distress occurs when you have issues in your gradation design, or if you have more void than the optimal void. And of course, it's related to aging also. If you do not estimate traffic loading for the design life, you will also see this kind of premature failure. But I do not doubt that aspect, because we do not have basically that much traffic in our province, although it's increasing significantly in the last 10 years. I'm skipping the consequence part, so you are all aware of consequence of rotting pothole in our transportation system. Pothole, as I said, it's basically water-induced damage that's I feel in our road. One of the major issues I see, we do not maintain proper side slope, proper crowning in our road, so water stays longer time in asphalt surface. So water is the enemy of asphalt. If it stays longer, you will see some kind of raveling and disintegration. And if we have other cracks, aging-related crack or thermal-related crack, that also turned into big hole, pothole by the traffic and further water action. So by improving the side slope or subsurface slope, we can reduce this kind of distress. For example, this pavement looks like pretty new road. Actually, it is new road because I took this picture. Okay, but all of a sudden, in the middle of the road, there is a pothole. Probably this is a construction issue, most likely, not properly compacted. Okay, so with the traffic stress, material is disintegrating. Delamination, it is a common issue in our highways. I drove from Illinois to Newfoundland. So when I passed the ferry, I took a lot of picture in our TCH. So this is one of the picture, 287 picture I took. I stopped every minute. I know that I need to understand better about our road, so I took the picture. So my wife was very angry on me, but I still needed to do that. Yes, Greg is smiling. So delamination occurs mainly from construction issue. If you have water in your pavement during the construction, in the underlying pavement, underlying surface, bond will not occur. Or if temperature is very low. So the top layer will gradually remove from the bottom layer, from the traffic stress, okay, from the loading. That is one of the potential issues. Other issues can be if we do not provide the adhesive coat, tech coat, in between the layers. So this was the issue found by the Auditor General report. Then I got clearance that they are now applying tech coat, Department of Transportation. And this can also occur if the thickness is not properly done. If we do not provide right amount of silk coat or the overlay, so that with the stress coming from the tire, it will remove. Again, you know the consequence of these issues. Fatigue-related cracking, we have less in our highways. I do not also expect that because we do not have that much traffic other than this Avalon Peninsula in our highways. But we have a lot this kind of cracking in our city roads. So if you do not estimate traffic loading properly, the expected traffic loading over the design life, you will see this kind of crack. The structural damage in the pavement. You cannot do anything if you see this kind of crack in your pavement. You need to reconstruct your road. Okay, you just cannot do overlay or seal coat to solve this problem. Then roughness index, this is basically coming from the poor patching work. So patching is a good thing to temporarily solve the problem temporary if you have pothole or some other crack. But if you do not do right properly, you basically further deteriorate the issues. One thing is poor ride quality, excess fuel consumption, damage to vehicle, lower vehicle life, road safety. But other thing is, I will go to the next slide. So say this is the patching work recently done in one road. So water from the main portion of the road cannot go to the side of the road. Water will find its way to go down. Okay, so you basically damage the side slope when you try to solve the problem. And if water can go to the pavement structure, you are further significantly damaging the pavement structure because it will go to base, sub-base, and then the soil. So your foundation will fail. And you will see a lot of other issues, rutting, settlement, and breaking. So this is another patching work from the city road. So clear, nice gap between the joint. Good room for allowing water to go into the pavement structure. So you try to solve the problem, but you basically deteriorate the problem. Transverse cracking, so from the thermal issues, thermal stress, from thermal changes. The main point here I'm trying to make though, this city do the crack sealing program. In this crack, you will see still some traces of crack sealant, but here it's removed after the construction. And same problem here. So we really need to first characterize the material that we do not allow the thermal crack. We need to properly characterize the material for low temperature. First thing. Second thing is we need to update our crack sealing spec so they stay for the design life. Longitudinal cracking. So if you joint construction is not properly done, low compaction is done due to stress, you will see longitudinal crack between the joint because of the stress concentration for the low compaction in the joint. So again, it's a construction issue. So also it can be introduced from the top-down fatigue cracking. Again, we need to properly characterize the material to reduce this kind of issues. And recently, my two graduate students work on to understand the climate change impact. So they first model the climate change prediction using two established models. One is called modified Morphis model, MIOMM. Other is sin 40R-1 model. Too complex and comprehensive. I'm just saying they use two established climate change model, how the climate will change, how precipitation pattern will change, temperature pattern will change. Then they use the pavement performance analysis program from University of Nevada, very expensive program I do not have here. Very expensive program. It's, I think, $10,000 to $12,000 just for a 1-year subscription, US dollar. So they helped us to do the analysis, performance analysis, and the result was really very bad news for us. So all the cracking will be further deteriorated by this climate change, including rotting in asphalt layer, rotting in base layer, rotting in sub-base layer, and the fatigue-related cracking. So I shared this result with the Director of Construction in Transportation Works recently. This is a recent result, and we also will present this research in next year, next January, coming January in Washington, in Transportation Research Board Conference. So now in this part, I'll be talking about lots of positive, I mean, how we can work together to solve this problem. So as I said, my lab really wants to work with the government and industrial partner if we can work together to improve this specification, to improve the information needed to further enhance the performance of our roads. So I feel like this topic needs to be immediately addressed. First of all, in-depth review of our specification, construction specification, and develop our own pavement management guide for the highways and for the city roads. And then in-depth analysis on the rotting issues and water-related damages. Then life cycle-based decision-making tool for pavement management to reduce the patching-related issues. So for this, we really need to characterize the material using state-of-the-art facility, testing system. To my knowledge, we do not have advanced equipment, at least we do not have access. So we need to develop a lab in the province, central lab, that everybody can use, government engineers, municipal engineers, contractor, some kind of model we need to establish. And of course, my student and researcher also need to use. And we need some highways and street for road testing, and we can collect the data, and data can talk what we can do and what we cannot do. And this is little further thought. Say we have a rotting as a major issues in our road, so I feel like we need to collect the field core from different region, different cities, different highways, and then we want to do in-depth analysis of those cores, field cores, whether it is occurring in asphalt layer. If it is asphalt layer, we need to tune the asphalt grade. We need to probably introduce polymer if it is the issues. And if it is in the mixture design, we need to work with the gradation structure. And if it is in the subgrade, we need to come up with the subgrade solution, but that is less likely because we are situated in strong metamorphic rock. So probably subgrade is not the major issue for most of our road. And for the water-related issues, we want to try with surface drainage improvement, slope improvement, and also if we can use some modifier to enhance the adhesion between the aggregate and binder using some modifier. And again, I want to have field test section where I want to have control section, improve slope, improve binder, or other mixture design like porous pavement, and to see which system performing better in our context. And for this, I think we really need to, as a university, we cannot do that much without the support from government and private organization. We probably need to form a formal group or formal committee so we can discuss this topic or issues more closely and come up with a plan if we can do something together. That's I'm proposing to form a working group in the province to discuss these issues in detail. Yeah, so I feel like the potential partner, of course, governments, cities, federal government also can help somehow, and civil contractor association and all the major companies also can be helpful, like other province they did. That's all from my side. Thank you again for listening.
Thank you very much, Dr. Kamal Hussain. That was very informative and shed a lot of light on the processes and also some thoughts on going forward in a positive way, as you say. So we do have opportunities now for questions from the audience, and I'm sure there will be plenty questions. So I will walk up this side with the mic to give you this to speak so everyone can hear your question, and Jackie Locke will be on the other side. So.
Yes, Greg Dalton. I'm faculty at College of the North Atlantic, and I noticed our logo wasn't up in your last slide, so I'd like to include the College of the North Atlantic in any collaborative research. My background is trobologist. I actually went to school with Greg at Waterloo and did graduate studies there. But my area is tribology of coatings, but at the tool die level, so thin metal coatings mostly. So this is totally new to me. But I did live in Sudbury where I had studs. And Sudbury doesn't suffer near the damage to the roads. But one of the things that I do see in Sudbury is rutting due to bedrock. And St. John's and much of Newfoundland and Sudbury both have a very shallow bedrock. So I'd like you to comment maybe on hillsides with bedrock and subsurface flow very within maybe a meter of the surface of the road, and how that might affect the stability of roads. Because the worst road in St. John's is Allendale Road for ruts, and that's a hillside going up a hillside. So I'm wondering how maybe the presence of subsurface flow of water might affect the road stability.
True. Thank you. It was a really insightful question. Yeah, for every distress I talked, it's not just one factor at a time. Multiple factors can play roles simultaneously. So water has issue in the rutting also. So if water continuously coming in the structure, so your fines in the mixture will go away, wash away. So it has a settlement effect, consequence, basically. So the portion you are talking about in the road, if we have a hilly area, the water is coming into the pavement structure, yes, that can contribute into the rutting, overall rutting. Yeah. Thank you. And sorry, I will include your logo in next presentation.
Also, if you could introduce yourself, if your name and affiliation would be helpful.
My name is Dick Myers. I'm a retired engineer. My question is regarding road salt. You didn't mention it. I'm just wondering why, or if you could elaborate a little bit more on why or why not it's important in this scenario.
Yeah. That's a topic, road salt, de-icing, pavement friction. It was my PhD research topic also. So I spent a lot of time on that. In this context, it's another big area of road management. One thing is how we can optimize the salt application, okay, using de-icing or anti-icing or pre-salt application. My first immediate impression was when I came here, we have in the winter really lots of warmer temperature cycle, okay. I mean, we get low temperature, below freezing temperature, a few days, I mean in the pavement level, ground level, but we have 4 degree, 5 degree a lot in the winter. So if you have above 0 degree, you are not getting ice, okay. So the surface will not be slippery. It's again water, okay. Water is not problem, like ice. Ice is the issue. To reduce the freezing temperature, you need depressant, that is salt, yes, sodium chloride, because sodium chloride can reduce the freezing temperature up to -23 C, theoretically, practically -10. So my first, I think I shared this also with our friends in Department of Transportation. We need to review our salt application guideline. Yeah, that's another area of a lot of things can be done. A lot of things can be done. So for another point I want to mention, salt does not have immediate impact in asphalt pavement. There has been research a lot on this topic in the US. And also recently New Brunswick did something in asphalt binder level. So yeah, salt, sodium chloride does not have immediate big impact, negative impact on the asphalt pavement, but it has on concrete. Yeah, but we do not, we are 90% road our asphalt road.
My name is Len Knox. I'm also a retired engineer, but I'm on the contracting side. I did my tour of duty as a president of road builders here in 1997. We talked about the same issues back then in 1997, and a lot of things has to do with more than engineering. It's more to do with politics. And well, we talked about road structure, not just the asphalt structure, not just the thickness, sub-base, from A, B, sub-base to the rock levels. And all these things would have involved a higher capital cost up front for a lower cost for the long term. But capital money is in short supply, and it goes back to the 60s when you have an election, you have to spread the asphalt around. So spreading the asphalt doesn't necessarily give you a good road base. And so my question is Memorial, I'm getting the impression you're not linked into the Department of Transportation as a partner. Like this is a public, or a lot of funds come from the public purse to fund one. I'm surprised that there's not a working group now between the Department of Transportation, and you're doing excellent research here. I know the government's been doing road tests for the past number of years on sections, testing different binders and aggregates and whatnot to see what the wear would be on the highway. So I guess my question is, how engaged is the transportation group with MON? And then how is that research then focused in making decisions down the road on how roads should be designed and for life cycle cost?
Yeah, so I get this question a lot. I'm positive. I think we will be able to develop partnership. It just takes time. I understand. It's not only our provincial government. I saw in other jurisdiction also, probably smaller. I mean, other government also takes time to develop something big. So we are in touch with Department of Transportation, in continuous touch. I'm hopeful that we'll be able to do something together.
My name is Robert Gill. I'm also a retired, non-practicing engineer. It gives me lots of time to write letters, complain, ask questions, and so on. And as Janet Bradshaw will attest to, and probably to her chagrin, just a couple of comments, probably adding to Mr. Knox's comments. You know, you talked a bit about, or showed slides with talking about our challenging environment here, physical environment. We tend to use that quite a bit here to explain why we have poor this and poor that. And it seems to me that if we have a rather unique environment for design and construction purposes, then maybe we should have the really best specifications to meet those requirements. Whereas it appears from some of the things you've said here and some of the things I've done myself, my own limited research, that rather than having superior specifications, we in fact have somewhat inferior specifications. So it's pretty difficult to tackle a problem if we're not using the right approach to begin with. And it's pretty difficult to get people to change, it seems. So that's one comment. The other comment, just specific to rutting, and I know you talk about this quite a bit, but I think we should, as you say, it's due to studs primarily, at least the most obvious parallel troughs in the highway, which you fit your tires in them. And the solution is eminently obvious, to ban studs. That also was the cheapest solution. The government, to my understanding, has moved to a more abrasion-resistant aggregate in their specification. I don't know how that's working out. I think they gave contractors, maybe some contractors here could respond to this, 5 years to meet the specification, starting in 2011. So by 2016, they should have been the actual specification should have been met. So there should be more of a movement to ban studs, and that would limit your research, I'm afraid. But we would get a solution rather quickly for most of the rutting problem. And tied in with that, and this is a subject which, or an area or an item that sort of prompted me to get involved with investigating. Investigating is probably too strong a word. Writing letters. After I retired, and that is, being an engineer, you don't have to drive very far on a rainy day, or didn't, and now we've got the roads resurfaced in the last couple of years. It's great driving for the time being. Didn't have to drive very much to realize what a big risk it was to be driving on the highway when the ruts are filled with water. And that was a public safety issue, and this prompted my initial query to my association to ask what the association was doing in terms of discussing the matter with government, trying to find out what the problems were and what the solutions might be, and so on. And this is where we are. I sort of signed off myself on my bit of research, if you will, now that you and others are engaged in looking at these problems. But I think it's incumbent on us as citizenry to make more fuss about about studded tires and the damage they cause. And as you say, they come with their own risks, which probably, if you look at it on the continuum of conditions and temperatures, road conditions, and so on, you might make an argument that it's riskier driving with studs than without studs in the wintertime, since most of the time, by far, you're driving on bare pavement with steel on your tires. Okay.
Question?
So,
is there a question?
I say good luck with your research, and keep up the good work.
Thank you. Yeah.
Okay, I have a question, unless there's one over. Is there another one? Okay.
Good day. My name is Steve, but I'm a colleague of Dr. Hussain here at the university, so we know each other well. I just have a very simple question. If at the end of your collaborations and working group, you do result in a change in the pavement specification, how long will it take to determine if there is a benefit in that change? Are you talking about months or years or decades before there's evidence that the change is positive?
So some of the changes I am thinking we need is you do not need further evidence. You are talking about science or against science. As I said, we have rutting issue, we have cracking issue. We need to characterize the material, test the material before you apply in the road, before you put down in the road for these issues. And you need to adopt or have some facility to test the mixture. And people are doing that. And in current system, the rutting system is missing, rutting testing system, and cracking testing system is missing. We just do strength test and some sort of adhesion test that is adopted in, developed in 1940s. That is indirect tensile strength test. So this basically does not cover the scientific portion of the testing of the material. Yeah.
Okay, don't see any hands. Maybe I'll just ask one last question then to wrap it up. I have a question about hydroplaning.
Yeah.
So 2 points. One is we tragically lost one of our dear civil engineering students earlier this year, Kayla Anderson, may she rest in peace, due to hydroplaning accident on the highway, and it was oncoming truck. That was the first thing. The second thing I wanted to say is I recall last year driving home at night. It was raining on the Outer Ring Road, and I was in a hydroplaning situation where I lost control, and it was one of the most terrifying experiences in my life. Fortunately, there wasn't a vehicle in another lane. So my question is, do we know really clearly what are the causes of the ruts and the grooves in the highway that lead to hydroplaning on our highways?
So, couple of potential reasons for rutting. As I said, first of all, if you see a depressed channel on the wheel path, vertical depressed channel, most likely something is grinding the surface. That probably enemy is stud. But if you see again depressed channel, but hump on the side of the wheel path or bulge on the side, I don't know you understand that. Okay, that is due to issues in mixture. If you do not select your aggregate gradation properly, you will see shearing failure in your wheel path. Or if you apply more liquid than the required, so you will see that kind of rutting, because liquid will go away from the wheel path, from the stress from the tire. So issues in mixture or stud is basically are the main culprit for those kind of rutting. Yeah.
Okay, actually we have one last question, and it's you.
You have a question?
Do you have a question?
Oh.
What is hydroplaning?
Oh, that's a very good question. That's a very good question. So basically, if you see water in the floor, and if you have slippery surface, slippery shoe, you will not be able to have traction. Yes, you will fall down. Okay, because your shoe cannot reach to the carpet or the tiles. Okay, because there is a water-thin film in between your shoe and the floor. You will slip quicker than if you do not have water. Okay, so that is hydroplaning. You lost your traction. Make sense? Okay. I want to add to your point. That's issues in highways, hydroplaning tendency. It's also issues in the city road, but there are other issues due to water accumulation on the rutted path. So when you drive on one lane, so if there is another vehicle on your side, on the side lane, and if water is in the wheel path, so it splash the muddy water on your dashboard, so it affects your driving capability. So I face a lot when you drive in the city road, so splashed muddy water coming in your windshield, so it affects the driving ability. I feel a lot. I just came here, yes, so I can compare. I did not face this kind of issues that much in other jurisdictions where I stayed. So that's another big issue, for, especially for our elderly citizens.
Yeah. Good. I think there may be more questions, but there will be opportunity to speak with Dr. Hossain because there will be a reception shortly afterwards. Kamal, thank you very much for this presentation. It was very informative.
Thank you. Thank you.
Just a small gift on behalf of the faculty. Thanks again. Very informative. I'd like to, before I pass it over to Janet Bradshaw, I'd like to just take another short commercial break. I know it's getting late in the evening, but we have a very special occasion this fall because it is our 50th anniversary of the Faculty of Engineering and Applied Science. In the fall of 1969, there were 155 students that entered a full engineering program for the very first time, Newfoundland and Labrador, here in a brand new Faculty of Engineering and Applied Science with a founding dean who was Dr. Angus Bruneau. Has passed away, but a remarkable career that he led and a legacy that he left with us. So as part of our celebration, we produced a video. It's a long video of 15 minutes. I won't show the whole thing, but I'd just like to show you the first 4 minutes so we get a glimpse of just a little bit of the history. If you're interested in seeing the full thing, you can go to our website or to YouTube and just search MUN Engineering 50th Anniversary. So if you could just bear with us, I'd like to just show you a few minutes of this beautiful video.
Engineering and Applied Science at Memorial University has a rich tradition of excellence in engineering education that dates back to the 1930s. For the first 40 years, a 3-year diploma program in engineering was offered, with graduates of the program moving on to other institutions to complete their degree. All that changed in 1969 when Memorial University offered its own degree-granting cooperative engineering program in 3 disciplines: civil, mechanical, and electrical engineering, as well as a Master of Engineering in the field of ocean engineering.
I think the biggest thing that we noticed was the broader range of faculty that were all of a sudden available in there. Before 1969, when the program really started, there were only maybe 7 or 8 faculty in the whole engineering school, and they sort of handled all the different courses. And I think the biggest thing among my classmates was a little bit envious of the ability to study at home or in Newfoundland the whole way through, and the fact that it was a co-op program, which we didn't have. And I think the co-op program was a major step forward in providing a much more rounded and versatile education.
My first impression of the engineering program was that I was starting a brand new program. They had a previous program, a well-respected program, 3 years at MUN. After that, move off to places like Dalhousie to complete the degree. We were in a brand new program. Great promise. It was a co-op program that attracted a lot of us, but there was also a sense of great change and newness. Many of the profs were new profs, and not only to Memorial, but to being a professor as well. And practically every class, the profs it was the first class that they taught on that subject. But the idea of being able to graduate from a pro-op program to get that experience along the way and help pay the bills along the way made a big difference to a lot of us. And you know, it was very important to be part of that program.
When we started the engineering faculty, it's interesting to know that was 50 years ago, and so the time round about of that year, there was the moon landing. So there was a great deal of interest in space, and we were starting a new faculty, and we couldn't go into space. So we were thinking, well, what is Newfoundland? What space is important? It's the ocean. So we decided, Dr. Angus Bruno was the first dean, and the faculty, we had discussions. We decided ocean engineering was going to be our main thrust of research. That was our space.
The ocean research of the 1970s led to projects involving iceberg towing and LoRa, the low-temperature ocean research activity, a cylindrical laboratory for conducting underwater research. These types of projects in turn helped to contribute to the development of the province's offshore oil industry. By the mid-1970s, Seacor and Nordco were established. The NRC was relocated from Ottawa, and St. John's was well underway to becoming the hub for cold ocean research and development. Over the years, the Faculty of Engineering and Applied Science has had a tremendous impact on the social and economic sectors of the province.
Our Faculty of Engineering and Applied Science has made so many major contributions and impacts on the province of Newfoundland and Labrador. Not only our current students through co-op education, but our professors in the research that they're doing, but also the accomplishments of our alumni, of whom we are so proud of. Many have gone on to build industries and companies in this province, whether it's the offshore oil and gas industry or the high-tech sector. We have entrepreneurs that have started companies and have been leaders at companies. They've built the economy and to the prosperity that we're seeing here today, and our wonderful standard of living in the province.
When the degree
All right. Special thanks to Jackie Locke, our communications advisor, for her great work in putting this together. So as you can tell, we're all very proud of the legacy that we have here in our faculty. So if you're interested, again, the full video is available on our website or on YouTube. Okay, at this point, I would like to invite Janet Bradshaw, again, CEO of Paganel, to come up to say a few words on behalf of Paganel.
And thank you, Dr. Hussain, for such an interesting presentation. Pavement condition, roads and highways in Newfoundland is always a hot topic, as is evidenced by the turnout here and the great questions tonight. It was really fabulous. And as you've said, our roads in Newfoundland and Labrador, they have to put up with a lot between, the rain and the studded tires and the freeze-thaw cycles that probably are there may be more than anywhere else. So I agree, though, with Bob that knowing all that, we need to be able to do better. And it gives me hope that you're working on wanting to do better here at the university with the team of talented people that you have, and to be able to then pass on better tools to our designers. I see that you are working with the City of St. John's. That's great. I hope that you're also going to be able to work very closely with the province. It's really important, too, that the public be aware of these issues. And so I really thank you for this tonight and inviting the public to it. Now, the drive across Newfoundland is long at the best of times. But to stop to take 287 pictures, I won't be doing that drive with you, Kamal.
I was driving from Illinois, 5,000 kilometers.
So at this point, Paganel would just like to invite everybody here to please join us out in the lobby for a reception where all of these people with the great questions and some of the people with the answers will be happy to discuss any of the issues further. Thank you very much for coming.